Okay, young minds, this is your well-rounded math teacher, Mr. Prakar again. And we're on Unit 1, Video 2, and our learning targets are this. I want you to be able to solve absolute value equations, which we'll later on get into absolute inequalities, which are a little bit more difficult, and convert units of measure. And the big thing with converting units of measure is it kind of attaches on to your testing. ACT testing. Okay. So first of all, absolute value. Basically, absolute value of a number is the distance away from 0 on the number line. So if you have 0 right here on the number line, and this is 7, and this is -7, basically this distance between 0 and 7 is 7 units. These two vertical lines here represent absolute value, so the absolute value of 7 is 7. Now the distance between -7 and 0, once again, the distance is just 7. So the absolute value of -7 is 7. Whenever you take the absolute value of something, you basically make it positive. So first thing we're doing with absolute value is a couple of evaluating expressions. We're going to use PEMDAS here again. Basically, we have to do everything that's inside the absolute value, and then whatever that number is, once we get it down to one number, we take the absolute value of it and make it positive. So this is 1.4 plus. First of all, 5 times -3 is -15. -15 minus 7. Now, a lot of people think, well, shouldn't we make these negatives positive? No, not till you get it down to one number. This is 1.4 plus the absolute value. -15 minus 7 is -22. Now you can take the absolute value of it, and you get 1.4 plus the absolute value of -22 is 22, and then just 1.4 plus the 22, your answer would be 23.4. So that's evaluating expressions with absolute value. This one's kind of a little tricky one because it has a negative outside the absolute value. So basically, no matter what, when you take the absolute value of it, when it comes out of the absolute value, you make it negative. So a negative, the absolute value of -4 and 21 is 17 plus 6.2. The absolute value of 17 is 17, but when you take it out of the absolute value and multiply it by this, basically that's a -1 right there. You get -17 plus, 6.2. Adding those up, negative plus the positive, there's more negative. So this becomes -10.8. And you can just add that up on your calculator. So, a little bit with absolute value. There's a definition up here, solving absolute value equations. Basically, everything inside here, your absolute value could be positive or negative. So, you're basically going to have two answers when you're solving these absolute value equations. It says here, ax plus b could equal c, or ax plus b here could equal -c, because no matter what, when you take the absolute value of c, you're going to get c. When you take the absolute value of -c, you're also going to get c. Now, if that's confusing, let's try and use some numbers to try and explain it here. What would x have to be in order to make this a true statement? First of all, right here, absolute value of x equals 5. In other words, what could you plug in for x there? I'll cover it up. What number could you plug in that absolute value and make it a true statement? Well, the absolute value of 5 is 5, and the absolute value of, yes, -5 is 5. So what I'm saying is, if I pull this x outside of there, x could equal 5. If I plug that 5 in here, absolute value of 5 is 5. But x could also equal what? -5. So whenever you're working with absolute value equations, you should have two answers. Unless you run into a problem like this. Think of an example where you could take the absolute value of something and have it equal a negative number. Nothing. The absolute value of 3 is 3, and the absolute value of -3 is 3. So if this whole absolute value right here is equal to -3, well, that's no solution. Nothing I could plug in for x right now would make this a true statement. Okay? Looking at another one. We're going to solve this equation here. It says solve for B. Okay. Well, first of all, tell me this. If I cover this up, what number could I plug in there for that expression and have it equal positive 3 on the outside? Well, first of all, everything inside there, which is B plus 15, that could equal 3, because the absolute value of 3 is equal to 3 up here. So we're going to solve this equation. Also, you could take the absolute value of negative 3. That equals 3. So basically what I'm saying is if I cover this up, what numbers could I plug in there and make this a true statement? Well, 3 and negative 3. So everything inside there, that absolute value, could equal 3, or B plus 15 could also equal negative 3. Basically, you take the positive and negative aspect of whatever this number is on the outside, and then solve your two equations. So subtracting 15 from both sides to solve this little equation on the outside here, B equals negative 12. Over here, subtracting 15, I get B equals negative 18. So my two answers are negative 12 and negative 18. For example, if I take this negative 12 and plug it in for B up here, I get the absolute value of negative 12 plus 15. Well, negative 12 plus 15 is 3. Absolute value of 3 equals 3. That's why negative 12 works. If I plug in my other solution for B, which is negative 18, I get negative 18 plus 15 is negative 3. But the absolute value of that is positive 3, and that's why those two answers work. So basically it's this. When I bring this over, what can I plug in there and have it equal? Well, here's a problem. You can't have anything besides the absolute value of whatever we're working with by itself on one side of the equation. So I got to bring this 4 over to the other side before I can start to solve this problem. So I'm going to subtract 4 from both sides. And what do we got here? Absolute value of 3n plus 2 equals negative 4. So what could I, if you're covering this up, what could you plug in there and take the absolute value of it and have it equal negative 4? Nothing. This is equal to a negative number right now. So this problem, it's kind of a trick problem, is no solution. So what I'm saying is, once you get your absolute value equation where the absolute value is by itself on one side, this number on the other side has to be positive, or your answer is no solution. Okay. This particular problem right here, there we go. I can't solve this yet. I can't set it up into the two equations because I don't have this absolute value by itself. I got to get rid of the 3 and the 4, and then I can break it up into its two equations. So I'm going to let you guys try that first, see if you can solve this on your own. So hit pause and go ahead. Okay, it should be done by now if you hit play. So some people get rid of the 3 first, some people get rid of the 4 first. I would get rid of the 4. I would subtract 4 from both sides. And we're going to take care of that addition, subtraction stuff before we get to the multiplication and division. Kind of working backwards from PEMDAS is basically what it is. I get 3, absolute value of x plus 5 equals 12 in this case. Some people use the distributive property here, and sometimes that works, but with absolute value it doesn't work every single time. So what I would do, just get the absolute value by itself. This is 3 times the absolute value of x plus 5. So what I would do is divide both sides by 3 first. Now if you use distributive property and you got the same answers that I do, that's fine. I'm just telling you it's not going to work every time. So I get the absolute value of x plus 5 equals, in this case, 4. Now this 4 is positive, so I can go ahead and break it up into my two possible answers. Everything inside there could equal the positive 4. Also, everything inside there could equal the negative 4. And then solve the two equations. Subtract 5, x equals negative 1. Subtract the 5 again. X equals -9. So -1 and -9 are my two solutions. Okay, into the conversions. One of the biggest problems we've had on the ACT and other tests in the past is students struggle with converting a little bit. So we're going to do some basic conversions that you will see over and over again. And here's the one thing. Most people know that there's 12 inches in a foot, but a lot of people don't know that there's 5,280 feet in a mile, or simply 3 feet in a yard. There's some metrics over here, simple metrics. 1 centimeter is equal to 10 millimeters, so on and so forth. And then time. So we're going to convert distances, we're going to convert time, and then also speed, like maybe miles per hour to feet per second, something like that. And we're going to use fractions, and we're going to try to do some cancellations. So if you kind of follow this, hopefully this makes sense to you. And if it doesn't, certainly ask questions in class tomorrow. How many seconds are there in 7 hours? So I want to convert hours to seconds. Now, I got seconds per minute and hours per minute, but I don't have seconds per hour. So that's kind of what we got to do. We're going to go to change hours to minutes first, and then minutes to seconds. So it starts out this way: 7 hours. Now we're not working with speed, so it's not miles per hour or something like that. So just put it over 1. 7 hours divided by 1 is still 7 hours. Now, the first thing I'm going to do is I'm going to convert hours to minutes. And we're going to do that little fraction over here, and it's going to equal 1. I'm going to put hours down here because I eventually want to be able to cross-cancel these hours out and eventually work it to just seconds. The only thing left is seconds. Now, and we're going to convert minutes to hours here. Well, how many minutes are there in an hour? There's 60 minutes in 1 hour. And 60 minutes divided by 1 hour, this fraction right here is equal to 1. So it's not changing the value of our 7 hours. It's just rewriting it in minutes. Now, I could do this. The hours do cross-cancel out. But now, I have minutes on top. I'm going to put minutes on the bottom right here so I can cancel those out. And we're going to go from seconds to minutes. There's 60 seconds in 1 minute. Once again, the minutes will cancel out. So I got rid of my hours, got rid of my minutes. Now all I have is seconds. And the way it works is this: multiply straight across. Numerator times numerator, and denominator times denominator. So I have to plug in 7 times 60 times 60. And we'll just plug that into our little calculator here. Seven times 60 times 60. And we get 25,200 seconds. Now, what do we got down here? 1 times 1 times 1, or just 1. But that's basically going to be 25,200 seconds in 7 hours here. So we just convert it. And we use fractions to do that. Let's try another one. How many yards in 198 inches? We're going from inches to yards. So usually just take 198 inches and put that on top. This is over 1 because we're not really working with speed, just inches and yards. So first I'm going to convert inches to feet. And then I can go from feet to yards. So I want inches on the bottom because I have inches on top over here. How do inches and feet compare? Well, 1 foot is the same as 12 inches. So 12 down here and 1 up here. And you can see right now, inches would cancel out. So we're well on our way to figuring out how many yards we're going to have. And now I got to get rid of the feet and convert that to yards. So being feet is in the numerator, I'll put feet down here, yards up here. There are 3 feet in 1 yard. And now the feet cancel out. The only thing I have left up here is yards. So if I multiply my numerators, multiply my denominators, and then divide, I'll have my answer. 198 times the 1 times the 1 is 198. And I'll put yards there. 1 times 12 times 3, that's 36. And the feet and the inches are gone, so there's basically nothing down here. So it's 198 divided by 36, and that's how many yards I'm going to have. And I think it is 5.5. Let's get our TI-84. Where'd it go? There it is. What do we have? 198. 198 divided by 36. Yeah, 5.5 yards. So 198 inches is 5.5 yards. Here's where they can get a little bit complicated, but I think you guys will be fine. How fast are you traveling in miles per hour if your current speed is 50 feet per second? Well, they give us feet per second like this. I'm going to rewrite it as 50 feet per, we'll say 1 second. Now, the thing of it is I got to convert feet to miles and seconds right here to hours. Well, you can only do one at a time, so let's do feet to miles. There's 5,280 feet in 1 mile. So, and I want miles. I want to get rid of this feet right here. It's in the numerator, so I'm going to put feet down here. Miles up here. 1 mile is 5,280 feet. So the feet cancel out, and I have miles. So there's one thing. Now you see the seconds down here? I want to convert that to hours. So first I'm going to convert seconds to minutes, and then minutes to hours. Seconds is in the denominator down here, so you need seconds in the numerator up here, minutes down here. There's 60 seconds in 1 minute. The seconds now can cancel out. And I know the fractions are next to each other, but it doesn't matter. As long as this is in the numerator and this is in the denominator and they're the same thing, you can cancel them out. I don't want minutes, so I have minutes in the denominator, so I'm going to put it in the numerator here. And I'm going to put hours right here. How many minutes in an hour? Well, there's 60 minutes in 1 hour. So now when we multiply, we have 50 times 60 times 60 in the numerator. And hold on here, I got to figure this out. Miles is fine. Oh, the minutes canceled out here. So the only thing we have left for labels is miles and hours, and that's what we wanted, miles per hour. And your denominator is 1 times 5,280 times 1 times 1. So really, we have 5,280 hours right now. And miles on the top, 50 times 60 times 60. Oh, let's plug that in real quick. 50 times 60 times 60. And we get that. 180,000. So basically, divide 180,000 divided by 5,280. 34, and if you round it, I'd say 0.1. 34.1 miles per hour. That's what your answer would look like. Now the last one there you're converting, what do we got? You're traveling 50 kilometers per hour. How fast are you traveling in meters per second? So you can convert 50 kilometers per 1 hour, it would be, to, and you want to end up over here with meters per second. So you got to convert kilometers to meters and hours to seconds. I'm going to let you guys try that one, but your final answer should be, I get 13.9 meters per second. If you didn't get that, you can ask me or one of your neighbors questions tomorrow. Otherwise, you can get started on your worksheet. Peace out.